to see what those were. So the 7.4 and 7.5 would be doing some triangle ratios. Go through what those different theorems are. 7.5 was really just the area and perimeter, those ratios. That was kind of a simple theorem. Read through it a few times and think about what it's telling you. The 7.1 was, or the 8.1 I mean. 8.1 was where we had the geometric means. There are, did I give you a sheet? Yeah. There are a couple theorems at the bottom of 8.1 which you can use in order to figure out some missing measurements, but I did not present it as you need to learn the theorems. We just tried to match up the correct things in the triangles. So figuring a geometric mean, matching up the triangles to find some missing measurements. And then 8.2 was the sine, cosine, and tangent. Those are some of the things. I'll try and give you some review problems when I give you the assignment. Okay, so what we're going to work on today is trying to find an angle in a triangle. Okay? For the first problems, what we're going to try and do is figure out which angle is angle A. Is angle 1 angle A or is 2 angle A? And the clue that I'm giving you is the cosine of A is 24 over 25. So knowing that, can we figure out what angle A is? Well, cosine is what over what?
Cosine is opposite angle
No.
over. Cosine is the adjacent leg over the
Adjacent leg over the hypotenuse. So let's go with like angle 1. If we did the cosine of angle 1 in this picture, what's the adjacent leg?
1.4 feet.
You guys see where he's getting that? This is the angle that we're working on. So the leg, the ones that make up the right angle, which one is adjacent to angle 1 would be this leg. So adjacent leg is 1.4, and the hypotenuse, can you tell that's the 5? Where the right angle is. Now I need to figure out if 1.4 over 5 is the same as 24 25ths. So how do we get rid of the decimal? You can do two things, I think, that would be easy. Probably the easiest. Probably the easiest is multiply by 10 to move the decimal over. Multiply by 10 on the top and the bottom. That's not 1.4 anymore. Now it is 14 over 50. And that can reduce to 7/25. So that one did not match. So I'm guessing it's angle 2. Let's verify to make sure. Cosine of angle 2, if we're at angle 2 this time, which leg is the adjacent? I'm kind of looking at you guys that were gone to see. Yep, 4.8 is the adjacent, and then the hypotenuse is the 5. So 4.8 over 5, again, we can get the decimal out of there. 48 over 50, divide by 2. That's the cosine that we wanted, 24 25ths. So which angle is angle A? Angle 2 is angle A. So we're using the clue about the cosine in order to figure out which angle it is. All right, if you got the idea, let's have you try one without me ahead of you. Looks like I did go into decimal. If you wanted to do it that way, you could. Okay, I want you to figure out if it's angle 1 or angle 2. The sine of angle A is 8/17. Figure out which angle.
What section is this?
This one is 8.3. You figured out which one? Okay. Decided? You think it's 2?
It's angle 2.
Okay, sounds like you're agreeing anyway. So you're either all right or all wrong. Angle 2 is angle A. Did you stay in fractions or did you go to decimal? Okay.
So what's the calculator?
And if you wanted to go to fraction or take the fraction into a decimal, that just makes this easier in this part because you're not reducing fractions, you're going to the decimal values. Okay. How about if the tangent is 1.875? Now this time I did not give you the fraction, so I'm forcing you to try it in decimals. Which one has a tangent of A to tell us what angle it is? Again, make your fraction. The only difference between this one and what you did on the last one is you don't have to reduce it as a fraction. Just divide those numbers to put it into a decimal value. Which one is it this time? What'd you get? Number 1? Correct. This is the type of problem that if you just know enough about the tangent, that it's opposite over adjacent, you probably don't have to completely get all the dividing done, because you want the tangent to be more than 1. Do you want 27 over 14.4 or 14.4 over 27? Which way would it give you a value that's bigger than 1? Well, you want the bigger number on top. So you want this to be opposite. So you can do some analyzing and probably figure out a few of those. That's what we'll do on some of these So when we do some of these problems, like what I was doing on 62, that's when we'll use the sine, cosine, tangent. We will have to do it in our lesson today, so hang on just a second, we'll get there. Okay, on Friday, one of the problems we did was the sine of 30 degrees. And sine of 30 degrees is 1/2. What we're gonna do today in our lesson is the converse of that, which means if you know the sine is 1/2, we want to figure out, oh, that's a 30-degree angle. So we're going to go backwards, knowing the sine and coming up with the angle. To do that, we use what's called sine inverse, or cosine inverse, or tangent inverse. This little -1, in this context, it's not an exponent. In this context, it is a function. We could do the sine inverse, the cosine inverse, or the tangent inverse. And this would be some notes here. If you know the sine of an angle, then if you do the sine inverse of that value, you will get the measure of the angle. I know there's a lot of variables up there. We'll put some numbers in a little bit. If the cosine of an angle is x, then the cosine inverse of x gives you the measure of the angle. If the tangent of an angle is x, then tangent inverse of x gives you the measure of 71 degree. Did you get tangent inverse that time? So what you're doing is finding the angle by doing the inverses. How do you know which inverse? The same kind of thing that we did yesterday, figuring out which one it was. All right, I guess if you were able to do what was on the board, you maybe don't have to practice these. Anyone having trouble getting those? Why don't you just try these and see if you're getting the values that I had. Again, degree mode. You're figuring out how to use your calculator. Sine inverse. Yep. So it's approximately a 58-degree angle. Anyone having issues? Okay, so again, those are the easy problems. All right, as far as your notes, skip too far back. But there's where I want to stop. Okay, we're going to do solving a triangle. So there's a term there for you to define. What does it mean to solve a triangle? What it means is we're going to find all the missing side lengths and all the missing angles. Once we're done with solving the right triangle, we will know every side measurement and every angle measurement. So how much information do I have to give you? Well, I could give you 2 side lengths. From that, knowing that it's a right triangle, you can find everything. Or I could give you 1 side and 1 of the acute angles, in addition to the right angle. So I'll kind of mix up your samples and do different ones. Remember that if you are trying to find an angle, and I'm going to put a note over here, to find an angle, use sine inverse, cosine inverse, tangent inverse. That's how you find an angle. Okay, so sample. Here's our first one. It's a right triangle. One leg is 5, the hypotenuse is 5.7. We're supposed to find the unknown measures in order to solve the right triangle. We've got a lot of things we've done so far. How could we find side ST? Pythagorean theorem. Let's do that. Pythagorean theorem. Figure out what ST is. Pay attention to which side's the hypotenuse. 5.7 squared minus 25. kind of an answer does it say? Do we need to do radicals or anything? We're just going decimal. Do we want the negative square root? For ST's length, would a negative make sense? No. So we're ignoring the negative and getting, it's about 2.74 nearest 100. Okay, 2.74. Now to solve it, we need angle T or angle R's measure figured out. So we can, if we get one of those, we can get the other one pretty easy. Okay? How do we find an angle? Use one of these inverses, sine, cosine, or tangent. Okay, Kelsey, should we find angle T or R? It really doesn't matter. Angle R, okay. And let's use the lengths that were given because we just rounded, and if we got the wrong value, it's going to throw off angle T. So let's use the 5 and the 5.7. So to figure out whether we'll use the inverse of sine, cosine, or tangent, we have to analyze like we did on Friday. Okay, so one side that we know from angle R would be called the opposite, adjacent, or hypotenuse. Adjacent. Adjacent leg. How about the 5.7? Hypotenuse. Okay, so there's one trig ratio, look through our SOHCAHTOA, one trig ratio that uses both adjacent and hypotenuse. Which one, Lucas? Cosine. Okay, so instead of using cosine, we're trying to find the angle. So to get the measure of angle R, we're going to do the cosine inverse. It's like saying which angle has a cosine of 5 over 5.7. You'll have to figure out if you can do that directly on your calculator or if we have to change it into a decimal first. Cosine of 5 divided by 5.7. And nearest degree, so it doesn't want decimals on the angles. I'm coming up with it would round to 29 degrees. Anybody having trouble figuring out how to do that? Okay. Got it. Then, if that's 29 degrees, what's angle T? We're going to do another trig ratio. How are you getting 61? Yeah, just triangle sum theorem could help us. So, measure of angle T would be 180. Subtract 90 and 29, or you could use just the 90 idea. There's a little bit we haven't covered yet, but check your book. So angle T would be 61 degrees. So we completely solved the triangle because we have a 90 degree. This is almost a 30, 60, 90, but not quite. Question coming up with any part of that? Okay, let's go to another sample. I have to click through the solving that I have. Okay, here's another one triangle. This time I gave you the 90, one more angle, and one side. What can you find? Anthony, what are you starting with finding? Okay, I saw you calculating. I just was asking what you were doing. You found angle D, and how did you find angle D?
I just added 90, 58, and subtracted by 180.
Okay, so just triangle sum theorem, it sounds like. So measure of angle D was 180. Take away the 90 and the 58, so you got how much?
32.
32 degrees. Okay. Okay, that's probably a good place to start. Now what? Can we do Pythagorean theorem to find a missing side? No, we don't have enough side lengths, do we? that one. Okay, let's try and find a side. Let's try and find side EF. And just in case Zach subtracted wrong, I'm gonna do the, well, okay, if you were saying sine, which angle are you using? Would that be with the 32-degree angle or the 58-degree angle if you're doing sine?
Oh.
Because you were doing
That was
opposite.
the opposite, and then that would be Jason and hypotenuse.
So if you did sine to find x, you'd be using the 32-degree angle. So I was thinking I'd use the 58-degree angle just in case Zach subtracted wrong and gave us the wrong number there. So I'm looking for the adjacent leg, and the thing that I know from the 58-degree angle is the opposite leg. So the trig ratio with adjacent and opposite is tangent. Okay, Grant, are you with me on that
Yes.
thinking at all? That does make sense? Okay, because that's what we did on Friday. So we just figured out its tangent of the 58-degree angle over 1. Opposite is 14, adjacent is x, and we cross multiply to solve. Cross multiplying would be x times the tangent of 58 degrees equals 14. So to get x, we need to cancel out the tangent of 58. That's gone. So calculator time, 14 divided by the tangent of 58. Says nearest 100. 8.75? Yes? Makes sense? All right, so that side was 8.75. How do we find FD? Could do Pythagorean theorem. Anyone thinking a trig ratio? Everyone's thinking Pythagorean theorem? Okay, 8.75 squared plus 14 squared will give me FD squared. 8.75 squared plus 14 squared. This is the number like 272.5625. But now I have to square root that. And I get, oh, I did something weird, it's an error. 272.56 square root. Square root. 16.51. And I'll put approximately because I rounded that. 16.5. Thumbs up or down? Making sense? All right, we'll put through that solving. We didn't have to use the inverse function at all on that one because we could just subtract to find the missing one. So let's do one more where you have to do an inverse. I won't give you any angle. Let's say this side is 10 and this side is 30. Find angle A. Find angle B, and find this missing side. I'll just see. You were doing the square root of 800. I think I had down that was 28.28. Okay, so that could be found easily. Now we have to find an angle. Looking at my notes, to find an angle, use sine inverse, cosine inverse, or tangent inverse. And I have to decide, okay, I'm going to find angle A. Do I want to use what I calculated, or do I want to use the original? Yes. Don't think so. This is the hypotenuse. All right, so I'm going to find angle A. So that means I'm going to use the adjacent leg, and I'm going to use the hypotenuse. The two things that I started with, Those are the most reliable. So to find angle A, the sine, or not sine, cosine inverse of 10/30. So what angle, oh great calculator, what angle has a cosine of 10/30? 70, it would round up to 1?
Yep.
71 degrees? And if I want to use that and subtract to find B, you could, or you could do another trig ratio. I'm going to guess most of you will subtract.
Right.
So if you missed that one, then you're going to miss this one too. 19 degrees. It's common to get those angles backwards, so take a look at the picture. Well, remember the theorem about the smallest angle is across from the shortest side? So that would help me know that the way that I have this, the 19 degree for angle B is correct. I'm going to guarantee somebody's going to get angle A as 19 degrees. But if you think about that in the triangle, then that doesn't make sense. It's across from the wrong thing. Okay, so that did stump some of you getting that angle. And that's the basics of this section. So how else are they going to present the problems? They're going to give you one where it's the coordinates. And so you're going to graph those. Again, we're trying to find the side lengths and the angle measures. So it's the same kind of problem solving the triangle, but they're just starting with it on a graph. So go ahead and graph it. What can we find easily without even worrying about the points? Okay, which sides can you figure out easily?
PQ is 5.
5, okay.
PR is
7. What else can you figure out easily? There's an angle, you know. Now, by graphing it, we can tell 90 for angle P. Okay, so if you imagine that was given to you now, not on the graph paper, how can you find the other things? How would we find angle Q?
Pythagorean. Oh, wait.
Not for angle.
Yeah.
I kind of changed up what I asked. How would you find angle Q? Look at your notes to find an angle. Use one of those inverses. Which inverse are we going to use?
Use the tangent.
Tangent, because we know the opposite leg and we know the adjacent leg, correct? So tangent inverse of opposite would be 7, adjacent is 5. So what's the measure of angle Q? Remember, it's usually said whole number on the angles. Is that 54 degrees?
Yes. 0.462.
So nearest degree is 54 degrees. And if I did that right, then what's angle R?
Uh, 36.
36 degrees. Okay, so 54, 36. What's the last thing I need? I need RQ.
It would be 8.6, which would be.
And how did you do that?
Pythagorean theorem.
Okay, you could do Pythagorean theorem. Can you think of anything else you could do?
The distance formula.
You could do distance formula using R and Q. You could even, now that we know an angle, we could use a trig ratio to find the hypotenuse. But I agree, Pythagorean theorem is probably easiest. What did you come up with?
8.6, which is rounded to like 9.
8.6 now. On the sides, I think they said hundredths. It was on the angles that they didn't want any decimal.
So 8.6.
So that's about 8.6. I'm just going with what he told me. Is he telling me the right thing? All right, so they're going to present it just in a graph format. That shouldn't be any different, but take a look at it on the graph paper so that you can tell some of the side lengths and which one's the right angle. Okay, so I had a second example, but I'm thinking that I'll skip through that. Confident you can figure that out. And then the last part is, what is a percent grade? Can you tell what my picture is there? Show up well enough? Percent grade is usually something they use to describe how steep a street is, like what the slant of the street is, like the slope, basically. But they're not saying the slope is 5/10. They're saying it's a certain percentage. And I want to check or see what some of those percent grades are really as an angle, and maybe compare it to some of the things you know. So this one's showing San Francisco, California. It's famous for steep streets. The steepness is a percent grade. Let's see, Filbert Street, steepest street in San Francisco. 31.5% grade. Okay, now what that means, here's probably what's important for you. The percent grade means it has a rise of 31.5 feet over a horizontal distance of 100. Where am I getting those numbers? What's percent mean? Isn't that an amount out of 100? So I'm really just thinking of this percent as the fraction. 31.5, can't write my 5. 31.5 over 100. And if that's describing slope, this is a rise and a run. So I can relate that to a triangle, which is probably on my next screen. But on a right triangle, I can say, okay, the rise is 31.5, the run is 100. So you're just taking the percent grade and interpreting that into the triangle measurements. Let's try and see what this angle is. What's the actual angle formed with the horizon? How do we find an angle? Sine inverse, cosine inverse, or tangent inverse? Which one should we use? We're trying to find this angle. We have the opposite leg and we have the adjacent leg. So tangent inverse. Okay, so tangent inverse of 31.5 over 100. So what angle has that as a tangent? Is it 17.5 degrees? That's what I have up here that I worked already. 17.5 degree incline. You have any idea what that's like? No? I think we had some problems earlier that had us figure out slope on a ramp. And if I remember right, I've read that problem a few times, for handicap accessibility, the ramp has to be between like 4 degrees and 7 degrees. We're in that range. So that would be pretty steep. 17 degrees instead of 7 degrees, how much it slants up. On a highway, let's see, I must have skipped over something. If you've driven in, let's see, here's my picture. Have you ever seen these signs down the highway? It's a lot safer that they get off the highway. So that was in an 8% grade. I'm going to flip back because this problem was figuring a 7% grade. And that was only a 4-degree angle. If you think on your protractor, 4 degrees, that doesn't open very big at all. But that's when they have to start warning, is when it gets to be bigger than a 4 degree. Here is the steepest street in the world. It's in New Zealand. Remember what I did? Let me flip back. Here's I probably should have taken more time to go through this one. But your percent grade, we're thinking of as a fraction, because then those numbers can relate to our triangle, producing a rise and a run, a vertical and a horizontal measurement, to help you figure out the angle. So what percent grade do we want right now? Is it 38%? What are we going to use as a fraction? 38% is 38 over 100. So that's your rise and your run. You're trying to find the angle.
So
That is
do
made
the
by the
tangent.
street. So do tangent inverse
Yeah, that's what I meant.
of 38 over 100. How many degrees is this angle? 20.8. So about, I'm gonna say about 21. When did they have to give a warning? 8%, which in degrees was a 4 degree, I think. This is pretty steep. Change it into a fraction, interpret that as rise and run, and you'll do tangent inverse to get the angle.